Hi, everyone, and thanks for joining us for another update from ValOre Metals. I'm Alex Heath, Strategic Advisor for the company. I'm joined by Colin Smith, Head of New Project Review, to discuss targeting methodology at the Pedra Branca project in Brazil. Colin, welcome.
Thanks, Alex. Yeah, and hello again, everybody. Thanks for joining us on another video here. I'll take you through briefly the generalized geology of Pedra Branca and sort of the target rocks that we're looking to find that host these layered ultramafic intrusions and ultimately the PGE mineralization. From that, we'll move into our targeting criteria. So what characteristics of these rocks can we use to help find them, based on certain exploration techniques. And then from that, we will go through each of the three target classes. So new discovery, target advancement type targets. So those are pre-resource and then resource expansion. So let me just share my screen here and we'll take you through a few slides. Excellent. So this is just a quick overview again. First, we'll take you through the geology and kind of the simplified strat sequence of Pedra Branca, and that's the target rocks that we're looking to find, and our exploration criteria. So how we are finding them, what exploration techniques are amenable to these rocks. And once we've built upon that, again, we'll go through each of the three target types as discussed before. So the targeting criteria. Now, on the left, you see a simplified stratigraphic sequence of what's called the TRAPIA unit. That is an Archean mafic to ultramafic locally unit that has been subjected to regional scale left lateral shearing, and that's created this large sigmoidal almond-shaped structure that essentially hosts these dismembered lozenges of ultramafics. And the zoom in of the ultramafic sequence, which hosts the PGE mineralization, is located in the middle column that you see here. Typically, what we see is an upper pyroxenitic phase, and this typically does not carry mineralization, but it's the units below that that do. So you get into a heterogeneous peridotitic phase, which carries grade. Then oftentimes there's a chromatite horizon, which is similar to what you see in South Africa. I mean, the rocks are the same age. They're directly related to the tectonization of West Africa and that rifting. So yeah, it really is the same deposit model in a way. And basal to the chromatite, which ranges from 30 centimeters to up to tens of meters in thickness, and that's where you get the high grade in the chromatite, the 10s, 20s, 30s, 40 plus grams per ton PGE. You have a basal dunite, and this also carries grade. But the important take-home point about these target rocks that you see in the middle strat section is the fact that they're quite distinct from the surrounding country rocks in a geophysical sense, geochemical sense, spectral sense, and raw data sense, and also, of course, geologically. The rocks that host the mineralization are typically quite magnetic, so there's a lot of secondary magnetite in the denitic phase. There's magnetites in the peridotites, and the chromatites are also occasionally magnetic. So they really do stand out in mag surveys, both ground and airborne. And because they're typically mafic to ultramafic in composition, they are situated in broad areas of radiometric low, so low potassic signature. Thus, a mag high and a radiometric low is something we want to take a closer look at. As you've probably learned from previous videos and just being familiar with the project, these deposits and the mineralization is really at or near surface. So soil geochemistry, in a part of the world where there's been no glaciation, not a whole lot of movement of superficial material, is really effective. It's really robust. There's not a target or deposit whereby, if there's a soil line that goes under it or over it, and there's mineralization, that it doesn't run. So soils are very effective. Now, worldview raw imagery, this is the highest res commercial satellite in the world. So just the raw imagery alone can really pick out these dark, distinct ultramafic to mafic rocks in relation to the more felsic gneisses that they're hosted in. Further to that, obviously the spectral data can infer that sort of prospective geology on a regional scale, but to the scale of 50 centimeters pixel size. So it's very, very powerful when used in conjunction with things like geophysics and geochemistry. Last but not least, the geology. So as I mentioned before, this broad ultramafic to mafic unit called the TRAPIA was subjected to left lateral shearing, and that ripped it apart, dismembered it into these discrete lozenges that are typically elongate in a east to west fashion and dipping to the east, generally speaking, which can help us a little bit in the mag inversion interpretation. So what you see in the bottom right here is just a zoom in of a portion of the Cedro deposit. The east-west lines are soil samples, so you can see the different elements that are kicking there. The faint blue outline here is the 43111 resource solid, which is dipping to the east gently, 20-25 degrees. You see the worldview spectral data as these color blobs here and swaths of color, different colors meaning different classes of spectral anomaly. And then in the background, you see the mag high that it's associated with. So this broad area of warmer colors signifying the mag high anomaly. What I'll do is just step into the new discovery type targets. So an example of this that we're very excited about is called the C11 target, which I'll move to next here. So where are we? We're literally across the road from Cedro. Where we were looking just before in that map, we're seeing a clip of right here. So we're 300 meters from a resource across the road. This is a main all year, all season access road. And you see a lot of similarities here. This is a big area of mag high, as you can faintly see in the background there. The 3D inversion model is in the middle panel, which is modeling that 3D mag isoshell, basically at depth. And then, as I said before, you're getting the same sort of worldview signature as you do at Cedro across the road here at C11. So we did some ground truthing in Q4 of last year, and what the geologists found at surface, right around where this drill hole is planned for, is peroxenite. So again, referring to the simplified strat section, where might that be in the ultramafic sequence? So on the right here, you see the peroxenite, as we discussed before, is sitting at the uppermost portion of the ultramafic sequence. Below that is where you get into the mineralization. So the peridotites, the marker chromatite reef, and then the basal dunitic phase. So what we're hoping, and we'll test by drill bit, is that we're looking at just the top of this ultramafic sequence. And as we drill into it, we will get through the peroxenite and hopefully punch into the peridotite, some chromatite, and obviously some PGE mineralization. Next one I'll take you through is the target advancement type target. So Santo Amaro, we talked about before, it has all three classes of targets. Specifically though, we're going to be focusing on the northwest portion of the target area. Now, this, target advancement refers to a target area that is pre-resource, so it's not tied into the current 43101, but there is a historical drill intercept that was not followed up upon for a myriad of reasons. Most likely for the case of Anglo, they were looking for massive systems, and this intercept was not something that they deemed they wanted to follow up upon, but certainly we do. It's sitting about a half kilometer or just shy of that outside of the resource, and as you see, the intercept is above resource grade, it's near surface, and it's totally open. We'll get to the trenching number just after this, but there's some nice trenching numbers that sort of connect or suggest continuity between the mineralization we see in the resource and the drill hole intercept to the northwest. And ultimately, we're going to be looking to test both the up and down dip extension of that mineralization that you see here in DD02, SA04, and I'll zoomed in on the right here. And ultimately, if things pan out there, and probably either way, actually, we're going to be looking to test potential continuity with the existing resource as well. So, I spoke briefly to the trenching numbers. Before I get into that, just to give you context, on the right here, this is a cross-section line right through the resource area. So these 5 drill holes represent these 5 drill holes here. So the section line is more or less east-west. And this drill hole here is the representation of DD02 SA04. Again, it's totally open to the east and the west. That's strike extensions we're going to test to immediately expand the resource. But also there are these more further afield targets, target advancement style, that have seen historical drilling, had a good intercept, but again, we're just never followed up upon. Okay, to further that, we'll discuss the trenching numbers, which I was referring to just a moment ago. Again, here are the 5 resource holes that we just saw in cross-section. The proposed holes are in blue crosses, and the historical drill intercept that's pre-resource, target advancement style, is sitting up here. Now, these are historical trenching numbers. We didn't do these trenches ourselves, but we, through the mining of the database, we were able to pull out these grade references for mineralized intervals within these trenches. Again, these are 3 that are sitting outside of the resource in the direction of the soil anomaly, in direction of some worldview picks, and also in the direction of the mag high. But most importantly, it's in the direction of the drill hole that intercepted in O2 and the drill hole that we're going to be following up. So, you know, these are pretty good numbers of decent grade, well above resource grade, 15 meters at 2.44, 41 meters at 2.35, almost 13 meters of 1.9. You know, those are great numbers, and we're excited to further test those. Ultimately, some of these drill holes that are located to the north of the resource, we'll be testing some of these further afield trenches. But, you know, it's exactly what you want to see, and it's something we actually see at TRAPIA 2 as well, which is a resource expansion style target, which I'll get into now. Okay, so here we are at TRAPIA 2. Much like Santo Amaro, TRAPIA 2 has all 3 styles of targets. So we have resource expansion, looking to grow the 43101. We have target advancement, so previous drill holes that have had intercepts but were never followed up upon. And then we have new discovery type targets, whereby in the case of TRAPIA and through the process of mag inversion modeling, we've been able to develop new targeting concepts, and we'll be testing those in phase 1, phase 2. So what you're seeing on the left-hand panel here is soil lines east-west. You have the mag anomaly, which again is coincident with the mineralization in the faint background. You have historical drill holes in white and black dots, rock samples in squares, and proposed holes in blue crosses. So we'll focus solely on the resource expansion type holes here at TRAPIA. One of the exciting things that came from the 3D inversion modeling of this deposit area is the fact that the historical drill holes actually missed all of the mag high iso shells. So as you can see, these blue crosses, these are proposed holes that are going to be piercing into these mag high iso shells. The historical drilling actually were sitting outside of those mag bodies. So even though they did intercept ultramafics, the grade was a little bit intermittent, and we believe that if you step to a position whereby you're going to be piercing into the core of these mag bodies, we're going to have much better likelihood of hitting PGEs. Now, I did mention before that there is some historical trenching data at TRAPIA 2 as well. And again, these are trenches done by previous operators. GenCore back in the late 80s did a bunch. I know Solitario and Anglo did some as well. And through the process of mining the database, we were able to find some references to historical grade intervals. As you see on the right-hand image, you know, not as high grade maybe as what we saw at Santo Amaro, but enough grade to suggest that there are ultramafics with mineralization, obviously at surface. These things are typically, again, dipping subtly to the east. So what you have here is a trench and then a historical hole that's stepped to the east. This hole in particular is of interest to us because it did hit mineralization, it did hit a huge swath of ultramafics. And I'll talk a little bit more about the BR series hole in a moment here. But ultimately, as I said before, we're going to be looking to step out and potentially connect these resource bodies, but also extend them along strike, because these mag isoshell targets are coincident with soil anomalies. They're down dip of trenches that run, and ultimately they're close to resource. So adding ounces should be fairly amenable to these holes. Now, I referenced the BR series holes. These were drilled in the late 80s, and through the process of verifying the assay database and drill hole database in general, we came to the realization that most of these BR series holes actually didn't assay for PGEs throughout the ultramafic sequences. As you see, the location of these BR series holes, there's BR21 here, BR22 is central to the 2 resource bodies, and then BR24 to the north. We're looking west in this middle panel here. And as you see in the shout out here, over 80 meters of ultramafics in BR21, 2/3 of those were not assayed. BR22, over 95 meters of ultramafics were not assayed. Same goes for BR24. Further to the BR series saga, if you will, is the fact that all of the core for these drill holes was lost in a motor vehicle incident, you know, many decades ago. And so from a resource point of view, we actually did not incorporate any of those assays, intercepts, or anything into our current 43101 resource. So some of these holes, you know, as you saw in TRAPIA 1, which was a video or two ago, are exceptional, great grades, close to surface. And, you know, in the case of these BR21, 22, and 24 holes, big swaths of ultramafics were actually left out of assaying for PGEs. We're not sure why, but we're going to look to re-drill those, and we'll do a quick sort of feature on some of these BR holes that were left out of the resource here. Okay, so just to get you situated, BR21, which is the left zoom in hole up here, is the southern of the three. BR22 is central to the two resource bodies, and BR24 is on the north side here. Now, again, intercepts like this were left out of the resource. BR21, you know, that's 60, 50 meters outside the resource. There's no reason why that couldn't have been pulled in, but there was no core. We couldn't verify the assays, so we went on the conservative side and obviously left it out. Of interest as well, though, is this large swath of ultramafics that simply was not assayed for PGEs. And you think, well, maybe it was a lithological explanation for that, but you know, you have chromatites logged central to that interval of unassayed rock, whereby you would want to assay those no matter what. Chromatites carries the high grades, you know, the 10s, 20s, 30s, 40 plus grams per ton. So, you know, we're going to go back in and re-drill some of these holes, assay top to bottom the ultramafics, and see if we can pull in some ounces to the resource. BR22 here, similar story, almost 100 meters of ultramafics that were not assayed. These are dunites, these are phases that carry grade in all of the other 5 deposits and many of the exploration targets. So again, we're going to look to re-drill those and assay the ultramafics. Ultimately, this drill hole that you're seeing just to the, what would it be, west of this body, again, was drilled too far to the west and actually did miss the mag isoshell. So we're going to step to the east and combining with the BR22 re-drill, hope to connect these two resource solids and add a lot of ounces there. Last but not least, we have BR24, which you see the far right-hand side of the northern section of the resource area. It had a intercept at depth, but again, the core was lost. This was not incorporated into the resource. It also did miss the main part of the mag isoshell. It's tough to see there, but it's drilled a little bit too far to the east this time. So we're going to step a little bit down from that, re-drill BR24, and also step up and drill into the core of the isoshell and hopefully pull in some more grades. So great example of mining the database, getting value from, you know, previous assays, but not incorporating it into the resource and incorporating that into our drill planning so we can ultimately add back some ounces. Back to you, Alex.
Thanks, Colin. Excellent overview. I'm really excited about getting this exploration program underway shortly. And thanks everyone for watching. If anyone has any questions about ValOre Metals or about the Pedro Branca project, please visit our website at valoremetals.com or send us an email at contact@valoremetals.com. Thanks again.